Hello, everyone. Thank you very much for joining today's session. I am Geology. I'm the Project Marketing Officer at Datamine, and I will be your session moderator today. First of all, this session will be recorded, but the Q&A and open debate won't be part of the recording. So this is your advantage of being here live today. I am surrounded by Anthony Cook, Datamine's VP of Geology, Kathleen Huntsman, Geology Product Manager, and Isaac's new Project Manager, Ophélie Lemarchand. I will now start by presenting you today's agenda. We'll start by a recap on the webinar series and the current methods of interoperability across Studio RM Pro. And follow with our plans to reinforce the interactions and sharing of data and results across the geology suite with MindTrust Online. We'll then jump on how we are enhancing the power of automation with Python in Datamine, and conclude with a Q&A and open debate section of this journey. I'll introduce my colleagues for you to know who you are talking to. So let's start with Anthony Cook. He has the technical qualification in geostatistics and data science, and a practical background in mine geology. Anthony understands the challenges faced by resource geologists. Anthony is passionate about helping geologists work better every day and leads the strategic vision for Datamine's geology portfolio. Kathleen is the product manager for geology, as I said before, and is specializing in Studio RM with a strong background in resource geology, implicit modeling, mineral code compliance, and advanced geostatistical methods. Kathleen brings a wealth of expertise to the role. Passionate about problem solving, Kathleen focuses on thoroughly understanding challenges and developing effective solutions to overcome them. And Ophélie is a seasoned project manager at Geosciences with over 16 years of experience in geostatistics and software management. Ophélie has been instrumental in leading the Isaac's new project, overseeing everything from development and testing to crafting technical and marketing documentation. Ophélie brings a wealth of knowledge and practical insight to every project she undertakes, with a background of consultant, mathematician, and geostatistician. Well, as you know, this webinar happens as a conclusion of the webinar series run in APAC, EMEA, and North America about Studio RM Pro. So we'll start listening to Anthony about this recap.
Thank you. So as hopefully everyone is aware, we hosted 2 sets of a webinar series over the past couple of months. And the products that we chose for those webinar series was Studio RM, Supervisor, and Isaac's Neo. And I guess it's a great demonstration of how each of these products can contribute to the resource value chain as a combination of products. And the 2 series that we hosted, one was in North America, hosted by Amanda and Sylvia, our consultants in the region. And the second one was in Australia, or the APAC region, which was hosted by T, Roberto, and Pedro. So one thing I do like about the process that was presented in the webinar series is that it's a fairly typical process that you would find for any standard workflow of resource estimation. So if we move over to the next slide, we can get a brief overview of what that process was. So we have everything that you might encounter, from importing drill holes from a geological database, desurveying those drill holes, doing some geological modeling, using the various tools that are available, performing your compositing, in this case by domain, and then going all the way through the EDA, exploratory data process, doing the top cut analysis, intervariography, all the way through to the estimation and interpolation stages. From that point, using the tools within the products to do your model validation and wrapping up with a conditional simulation, which is becoming a more popular technique to undertake the uncertainty analysis. It's a key input into a wide variety of post-estimation procedures in risk analysis, classification, and generally just understanding the uncertainty and the optimization of your resource. So if we look at the webinar series in particular and which products we chose for this process, we can step through, first starting with Studio RM. So we chose this because it has the drill hole importer, which is a really nice tool for getting those database exports together and creating those drill holes to begin with. We went through the whole process that I mentioned about the wireframing and compositing. Moving into Supervisor, our flagship for data exploration and data analysis, with a real focus on how Supervisor uses the tools and components that it has available to really allow people to get into the manual processes of data exploration. And we really like to focus on that because generating 2D charts and plots or a series of plots really isn't interactive with your data. And so having a tool set that allows you to really get into the data, explore it, look at it in 3D, do some analysis on that is really what we mean by exploratory data analysis. Then into Studio RM. So in this case, we decided to showcase the dynamic anisotropy, soft boundary estimation with some local grade capping. So just a nice mix of typical search parameters that you might want to apply for just a fairly standard workflow. Moving from there, we leveraged both RM and Supervisor for some of the model validation tools. So Supervisor has its own suite of tools, while Studio RM has the obvious 3D environment that you can step through and really check against the input data what you're actually getting out the other end. Finally, like I mentioned, it was great to be able to wrap up this particular workflow with some of the simulation tools that we found in ISATIS. And again, these are becoming more popular. We're seeing them getting used, particularly now that we have tools which are much easier to use to get into the process itself. And one thing about ISATIS is that it is extremely powerful with just the breadth of the statistical tools that are available. And unfortunately, we wanted to keep this process simple. So we didn't introduce too many of these extra tools in, but there is quite a range. And Ophelia, do you mind sharing some of the ones that we didn't have a chance to show off in this series?
Yeah, of course. ISATIS Neo benefits from most of the estimation and simulation methods based on kriging techniques to deal with specificities on your data, such as faults for taking into account geographic discontinuities, consider a multivariate model, local anisotropies, etc. But I can highlight also the unfolding, which consists in flattening complex geological structures. ISATIS Neo benefits from a new exclusive algorithm based on the landmark multidimensional scaling method, particularly recommended when dealing with highly banded surfaces. It uses two reference surfaces, top and bottom, that are flattened using multidimensional scaling, and the folding objects, as well, for example, which are mapped to the flattened space. You achieve the biographic analysis and estimation in the flattened space, and after you do the back transformation of your estimation to the real world. We also have the sample clustering. This application is designed to assign each sample to a domain using a geostatistical hierarchical clustering algorithm. This algorithm provides a sample classification into domains, respecting data connectivity and similarity. It also allows getting the domain categorization for added sample using unsupervised machine learning algorithm. It's very interesting to help the definition and classification into domains. And to finish with some Isatisneo tools, speaking about domains, we also have the pre-regression simulations, which allow simulating the spatial distribution of categorical variables like geological facies or rock types with a pre-regression model. This implementation of the pre-regression simulation methodology is innovative and different from the usual implementations. The PGS method is another way to estimate the geology by constraining the lithological models to geostatistical and lithostratigraphic characteristics.
I quite like the folding methodology that you have in ISART. So it would be good to get a webinar series perhaps that uses that technique. And in addition, I've seen some great stuff with the pluri-Gaussian simulation as well. And I believe that GeoVariances has a paper that can be read for anyone who's technically interested.
Yeah, we have several papers available on our website, but we can share them if you want to have some details.
Yeah, that'd be fantastic.
That's great.
So just a reminder to everyone that if you happen to miss any parts of the webinar series, that we will make the links to those recordings available to you. We very much appreciate any feedback on the series itself. We're looking forward to providing more series of this type if you are interested. And again, using all of the tools that we have available to explore different types and different processes that we can do with the vast tools that we have available. So please watch those if you miss them and provide us feedback.
So now we're going to delve into my interests to show you how we are willing to enable a connected experience across the geology suite. You want to do that?
Thank you. Yeah, so one of the really exciting things that we're tackling at the moment in the geology portfolio and within the DataMine ecosystem is really something that builds upon what the webinar series is about, which is the ability for us to use disparate products or multiple products as a combined solution. So if we have a look at the solutions that we have available on the next slide here, you can see that in the geology portfolio, we do have quite a broad range of tools. Sorry, next slide. So you can see that there's quite an impressive breadth of tools available to us in the geology suite, scanning everything from data capture, so with our mapping and analysis tools, all the way through to the modeling. We have the modeling and data analysis tools, and then into the interpolation, and of course, some of the more complex data science techniques. In addition, we also have some process flow-based tools as well. And what we want to be able to enable is really to customize within the resource space according to these. And there is a danger of taking any one tool and trying to cover the breadth of ground that a suite like this covers. And that's usually that as you add these capabilities to a single tool, not only do you add complexity, but you reduce the usability of those tools. And that's something that we want to avoid because we understand the value of dedicated, uniquely designed tools for specific parts of the geological resource process. And so to combat that, we've begun designing, or we're in the late stages of building the MineTrust data layer, or the managed data layer. And just to step back briefly about how this looks, if we move to the next slide now and consider the resource value chain to be the scope of work from the perspective of a geologist or a mining team. At the moment, we have our various DataMine applications, which sit separately. And generally speaking, it will require some manual file-based saving it to directories, using emails to let people know when things are ready. And we can alleviate some of those processes by implementing some API connectivity between those processes. But this is a limited game where the more applications we get and the more APIs that we need to support is going to become more and more difficult over time, especially when we start considering including third-party applications into that, which is something that we're very interested in enabling so that we can help so that we can partner with those up and coming new technologies. So the solution that we are proposing, or which we are delivering, is on the MindTrust managed data layer. So this is either a local or a cloud-based service. And what this provides is a common interface between our applications and the data layer. So in doing so, we remove the reliance on our files to be saved to an external place, removing the import and export applications between them. And in doing so, it is MindTrust that then interacts with the resource value chain and creates what we refer to as a mining system as a whole. In addition to this, we can then include some enterprise level integration, again, interacting with the data that we have on the MindTrust layer. And that again feeds back some analytics on the data that we have available into the resource value chain. But perhaps it's easier to use a worked or a visual example of this. So if we consider in the next slide that we have the full range of our data mine products as a whole, what this may look like on an individual level, in the next slide here, is if we take a typical flow from resource model or grade control model down to the drill and blast, MindTrust facilitates the flow of information in this kind of story. The geological model is created by the geological team. Once it is complete, the underground engineers are notified that a new geological model from the July period has been approved by the senior resource geologist. This notification means that the model is now flagged and becomes visible within the Studio UG environment. After selecting that model, the designs and the plans can be created. And once those plans are then signed off and published, these again are managed by MindTrust with various tags to ensure that the survey team is aware of them. And when survey pickups are done, those shapes and volumes, once they are signed off and tagged, all flow through to the drill and blast planning tool. And in this case, we have Aegis there using all of those inputs to then create the drill and blast, which then again gets signed off and flagged and moves down the process. This is what we mean by a data layer that manages the data for you, to take away the onus of having to manage things, manage multiple versions, temporary files. All of this is now possible to be managed by MindTrust itself. And although it's a bit early for me to be going into a full announcement of what we've achieved, there are some things that we can talk about for what we are currently implementing in Studio RM. And so, Kathleen, I know your voice is a little bit rough at the moment, but if you don't mind just sharing some of the stuff that we've been able to achieve so far.
Yes, of course. I'm not quite sure how it's going to come out. So Studio RM doesn't currently have a formal data management layer. To do this, you need some sort of custom application, some sort of script, maybe an OR controller or some macros, which and several other vendors have even built systems which sit on top of Studio products, which are essentially there to manage the data. Sorry. So this, and I mean, those kind of systems, basically what they're doing at a data level, they're sort of controlling the flow of data at the end of activities out and then back in again. So at the particular time, you're using the data that you need. So this, we have a lot of flexibility and versatility inside Studio RM now without the data management, and you want to keep supporting that. But we also want to provide more and provide something which can give customers a way of controlling these flows, but also without forcing the product into a square box, which it is not. So with the first principle of what we're implementing now is we want to make Studio RM a true multi-user system with the options of scalability at the data management layer using MindTrust. And MindTrust, if you think about it, is at a very simple level, it's a data lake. It's a system where your files are synchronized from your system machine onto a server with a lot of attribute data about the data, which helps you contextualize it. So this has been developed. We've done not within Studio RM, but one of our products in our portfolio, Studio Map. We've done a POC where this is working on site. at a commercial system. Fortunately, at this point, we can't share the name of that site, but it's there and it's working. I won't go into the full security model, but the full security model is there. And as we announce more, more detail will come out about this. And, also all the files are also visible through a web portal. So once you've uploaded the data, someone who's sitting at a management level, they can come and see all the data and access everything through external to the products and all the data there, see the files and the version history. Essentially, the purpose of doing this is to remove the risk of your data sitting with your individuals. The data then belongs to an organization. Organization has full ownership, and if a user's laptop gets stolen on the weekend, you're not going to lose your resource model because, the user hadn't backed up or application. Okay.
Thanks. Yeah, ultimately, we're extremely excited to be building a tool that does allow our multiple products to be working together seamlessly, with data from one working like magic to appear in one of the others when it is available and when that flow is desired by our users. So watch this space.
Okay, so we're going to now present you how we are willing to enhance the power of automation with Python in DataMine, starting with Aaron.
Okay, so me again. Sorry about the voice. let me keep us a bit briefer than I'd intended. So there's a long history of automation within the DataMine suite. I think it's quite a fair claim that we could say we were doing this first. In the early days, we were talking 40 years ago, with the ability to have to develop macros and allow our product to be automated. This is obviously in parallel happened with a lot of other software vendors, with our Citus and their journals, batch files. And this, the advantage of these processes, it allows a very complex workflow, which is developed by an experienced user, which then can be run by someone on the mine, and you ensure that junior person's running everything correctly, the right way, the right parameters, and you have full assurances that it's an auditable and transparent task that they're running. These kind of experimentation of setting up these scripts and macros, it helps you to advance and to discover new stuff and do things which, this kind of get always ahead of the software vendors because you're doing more. With us moving across to Python, so what is Python? For those who don't know, it's a high-level object-oriented programming language. With the recent rise of AI and also the common appreciation of data sciences, we've seen a massive advance in the data science communities who are utilizing Python in so many aspects. And building the equivalent process through Python versus building through an older process gives you access to more free libraries, your NumPy, SciPy, Python, Matplotlib. Lets these processes become more complex and do a lot more. Also, I think I'll leave it there. Ophelia, can we hear a bit more about how this is done in our Citus Neo today?
Yeah. So as you said, the Python language becomes more and more popular. It's a favorite language for many data scientists. So it came out for geosciences that we should provide some solution based on Python. In Citus Neo, Python appears at several locations. So firstly, in the calculator is based on a data table that it loads, and it enables you to make some operations and transformation on variables. This calculator uses the Python language, so it's very powerful. Some Python modules can be used to import external data files as CSV or Excel files, for example, to consider on which you want to apply the calculations, or also a file containing some parameters. And of course, we have the same output facilities to export, for example, the results or your calculations. You are also able to display some graphics using Matplotlib and produce some reports in PDF or Word files. In Citus Neo, you can also deal with batch files to automate your geostatistical modeling workflow. A batch file is basically a list of tasks to be run but it can be enriched by use of variables, loop, conditional statements, and Python code. The same use of additional Python packages can be done directly in those Python blocks or code when you don't need to work on a specific data table. Those external Excel parameters you'll be loading from here can then be used to change the parameters of the task being run in the batch file, for example, to run domain estimations. Another usage that this enables is the loading of a Python GUI package to create a customized interface. The new interface, as shown here, embeds a batch workflow, which are coded parameters defined by the expert user or just statistician, giving access to only few parameters. You can change the language, up to the logo of the company, etc. The last way to deal with Python is ExaType. We can go to the last slide. ExaType is a just statistical package. It can be used along with a vast range of Python libraries directly in a standalone Python environment or in Jupyter notebooks to test configurations and automate estimation procedures more efficiently. It's running outside of ExaType projects and without having the need of our user interface. The objective at mid-term, long-term is to provide all the different geostatistical algorithms available in ExaType. Kathleen, do you want to continue with Studio, if you can?
Yes. Oh, sorry, and again, I'll be brief. In Studio RM today, we've developed a DM-server.py library, which is a wrapper around all the processes and allows you to run DM server commands in a Python interpreter, Jupyter notebooks. So this allows, this works today, and this allows us automation through this layer. We want to extend this to allow for script recording, so to make it more accessible for users. This has been, from users that told us this is a very important part. It allows you to work in the same way you work now with scripts, macros, and to, to help you sort of get over that hurdle of the syntax if you're someone who hasn't worked with Python previously. And really the vision here is to enable cross-product processes. If you can run something which harnesses the block modeling and implicit power of Studio RM along with the simulation of Supervisor, I think you've really putting yourself in a really good position, especially then with all the free libraries available to supplement this.
Absolutely. I think there's so much opportunity by leveraging these tools in an automated workflow. By just, like you said, being able to bring in the vast wealth of external open source libraries which are supported by the enormous Python community. It is something that I've been working with Python for some time. There's some extremely novel and interesting techniques that we can enable through the use of, well, in my personal experience, using icertis.py alongside some of the data science libraries that we have free and open access to, and building out those customized workflows to tackle things in new ways. I do look forward to seeing how the industry is going to use this and leverage these tools. And really, it's up to us to provide this as an opportunity and then build upon this to make it easier and easier for people. Python is a very easy language to use, and even more so in today's environment, where we have tools like the generative AI models like ChatGPT, which are extremely competent in writing simple Python code. I do believe that it's something that is not out of bounds for anyone at this stage, especially the talented people that we have in industry in the geostat space. So, like I said, really looking forward to seeing what people come up with these tools.